Okay, so each one of these things in this setup is running software. It's running a special software that Cisco developed called Cisco iOS software, which stands for Internetworking Operating System. So these things aren't running, Windows 10. They're not running Mac OS or anything like that. They're running a special software that Cisco developed called Cisco iOS. And so I'm going to need to connect to each one of these things to configure that iOS. When I say configure it, that term might be foreign to you. When I say configure a router or switch, basically what I mean is let the router or switch know, hey, something's connected to this interface. Here are the parameters this interface needs so it can talk to that device. Here are the parameters or commands you need to talk to this other device. That's what I mean by configuring it, typing in commands so that the device knows what it should do and how it should do it. So I need to get access to these devices so I can do that. So there's what's called in-band and out-of-band connections. So here's what I'm going to do. Every single one of these, and I think I've got another picture of this, every single Cisco router and switch that they sell has a collection of interfaces, and you can see those interfaces on here. And one of those interfaces is very special. All right, let me bring this up right here. And we call it a console port. So let me make this bigger for you. So if you can see this right here, if you were to zoom in on my routers or switches, you would see that one of the interfaces is actually labeled. It might not necessarily be blue, but it'll be something that'll say console. And when you first purchase a router or a switch from Cisco or anywhere else, the configuration is going to be empty. It's not going to have any, it's going to have what we call a default configuration, meaning it doesn't have the knowledge it needs to do even the most basic primitive of operations. So you need to connect your laptop or PC to this console port to be able to configure this device. Now, once I have provided minimal configuration, like in the world of networking, in order for computer number 1 to talk to computer number 2, just like if you're going to send a letter from your house to your mom's house, what's the absolute minimum requirement that you put on that letter? An address, right? If your mom's house does not have an address, the network, which is the postal service in this case, has no idea how to deliver that letter to its intended destination. Same thing is true in computer networks. Every computer device, whether it be a smartphone or a tablet or a laptop, has to have some sort of a unique address so it can send data to other addresses and it can receive data, and it knows when that data comes in, oh, this data is coming in to my address, it must be for me. Now, the most common type of address that you would see in the world of networking is what's called an IP address. IP standing for the Internet Protocol. Back in like 1974, 75, right around that time frame, some very smart people got together and they said, we need to develop a set of rules, a protocol, because that's what a protocol is, a defined set of rules for how to do something, a set of rules so that computing devices can talk to each other across a network. And they developed the Internet Protocol, a protocol for talking over the internet. Now, within the Internet Protocol, there's a lot of rules, but one of the things that's in there says devices need an address. They need a descriptive identifier to talk from PC A to PC B, or PC A to server B, however you want to say it. So an IP address is that unique identifier. Every device, your smartphone, your laptop, has an IP address. What does that have to do with this console port? Well, initially, routers and switches don't have any IP addresses. None, zero, zip. So the only way I can get into the command line to configure it is via this console port. But once I connect to the console port and I have access to the command line, one of the first things I can do is put an IP address on that device. And actually an IP address belongs not to the device itself, and that's where it's a little bit different, right? When you think of like a postal address, like 101 First Street, that is the address of like your entire house. But think of your house as like this. Think of your house, your house has many doors, right? You've got your front door, you've got your back door, your door to your garage. Those are all entrance points into that house. Well, similarly, on a router, if I go back to my picture of the router here, right, let's, for example, look at this top router here. This router has multiple entrance points into the router. Here's a way that data can go in and out of the router. Here's another way that data can go in and out of the router. This is a special way. There's another one that could go in here. So these addresses called IP addresses don't go on the router as a whole. They go on these doors, what we call interfaces. So in this case, I've drawn like 4 interfaces. Every interface on the router, every point where data could come in or go out, needs to have an IP address so it can talk to the internet. It needs to have a descriptive IP address. So when I connect to the console port of this device, which is right here, one of the first things I have to decide is, okay, of all my different interfaces I have, which one am I going to connect to the network? And whatever interface that is, and there might be more than one, what interface that is, I need to put an IP address, a descriptive name or identifier on that interface. Once I do that, so once I've identified the interface, I've cabled that interface up to a functioning existing network, and once I put an IP address on that interface, now I don't need to connect to that console port to get into the command line of the router or the switch. I don't have to be physically in front of it with a little cable to connect. I can actually be thousands of miles away, and using the internet protocol, I can send IP packets, which are units of data, from my laptop through the network, going into this interface, and I can get access to the command line that way. But I can't do that at first. At first, I need to connect to the console port. So how am I going to do that in this particular case? Well, at minimum, so each one of these console ports, let me go back to the picture right here a little bit bigger. You can see they have a special type of jack. And I have in front of me here all kinds of cables. I got this, let me expand this here a little bit. Oops, not that. Let's see, how do I do it? Nope, not that. I'll figure it out one. There we go. So I got this great sort of pink cable right here. I got an orange cable right here. I got a whole slew of black cables. I got this nice looking blue cable right here. So the first thing I have to be aware of is which cable is appropriate for connecting to that console port. Let me get back to this. So number one, if I take a look at the size and shape of the console port, all right, and I got another cable right here. So would this cable be appropriate to connect to that console port? Well, I don't know how well this is coming on your screen, but you can see that the size and shape of that cable and the end of that cable is not appropriate to connect to that console port, because this type of interface is different. We actually call this type of interface a registered jack. So you might see this term RJ45. Let me draw this on here. RJ-45. That is what all of these are. Each one of these is an RJ45 jack, because you can see they all look the same. They've all got the same form factor. So this is the female end of an RJ45 jack, and the male end looks like this. All right, and I actually have a better picture for you that I can show you that's bigger. So for example, right there, that is the male end of an RJ45 jack. So clearly, any way that I'm going to connect to this console port, if I'm going to connect to this, it has to be one of these cables that has one of these ends on it. So knowing that, I can take this cable right here and say, okay, clearly that's not going to be used to connect to the console port because that isn't the right kind. But I still have, like I said, I got red, I got black, I've got yellow right here. And this is where you just have to know this. So a console port, when you buy a Cisco router switch, you get a special cable, at least hopefully you will, that looks like this. So this cable right here it does have an RJ45 connector on the end of it, and this is what we call a console cable. It's a blue, it's a flat cable, and one end of the cable has an RJ45 jack. Let me go ahead and disconnect this here. And the other end of the cable is something different. If I can show that to you right there. So here's my RJ45 jack, and this is what we call a DB9 connector. You don't have to memorize that. Main thing you have to realize is that, hey, this type of cable right here is clearly different than this type of cable, because this type of cable has RJ45 on both sides. This type of cable does not. So this is what we call a flat blue Cisco console cable. This end of it right here would go into the RJ45 jack, the console port, and this end right here fits into your laptop. Now, most laptops these days don't have connectors that look like that. There's no place to plug it in. That's why I've got this nifty little tool right here. So this is a DB9 connector on one end and a USB connector on the other. So I'll just connect those guys together, connect my cable together, screw it in a little bit so it doesn't fall apart. And I'm going to connect my USB port here to the console port on my devices. Now, if I want to configure all these, which I will, option number one is I could connect to the console port of this first router, spend a little bit of time configuring it, disconnect the cable, connect to the console port of the second router, and do that one by one by one, configuring them all. But there's a much easier way to do this. So this guy right here in the middle, this guy right here, is an old Cisco router that you actually can't buy anymore. It's called a Cisco 2500 series router. But it's special in the fact that it has, let me go ahead and make this a little bit bigger. Right there. Expand this. Right there. So it has these special interfaces right here. Notice they're called async 9 through 16 and async 1 through 8. This particular router is what we call an access server, sometimes known as a terminal server. What's so special about it? Well, these interfaces over here on the right, serial 0, serial 1, AUI, these are networking interfaces, right? These are interfaces that you will need to put an IP address on them, connect them with special cables to a network, and then they can send and receive IP packets. However, these interfaces right here are not like that. An async interface connects to a special cable called an octal cable. Now you might be wondering, what does an octal cable look like? And that is this right here. So notice, it's got a special connector, all right, which goes into, so I'll go back here, so back and forth. So that connector will go into this. And then this cable has 8, that's why they call it octal, 8 cables snaking out of it. And at the other end, each one of those has an RJ45 connection. Hey, that's great, because what I can do is I connect each one of these to the console ports of my various routers and switches. So now, once I have this cable here connected to my terminal server, which then spreads out to all the console ports of my routers and switches, all I have to do is access this guy. Let me go back here a little bit. All I have to do is console in. So basically I will establish from my laptop will have, so I'll go ahead and draw my laptop over here. So here's my laptop. I'm going to have my USB. So here's my USB connection, and that will have the blue flat cable, that blue cable, which will terminate right here into the console port of my terminal server. From there, I'll get access to the command line of the terminal server, and once I have access to that command line, using the octal cable, I can then get access to the console ports of these various devices via the octal cable. So I don't have to plug and unplug from each one of these things. Now somebody asks here on the live question feed, do we need to know the configuration of a console cable? You don't have to know, when you think about cables, for example, this and this, obviously there's some big differences between them, right? Just by looking at the color, but the color is just cosmetic. But inside, the differences between the ends, right, the connectors, even between the pinouts. For example, both of these, so this has an RJ45 jack, this has an RJ45 jack. Both of these are meant to do the exact same thing, connect into the console port of a router or a switch. However, I'm going to put my octal cable aside here for a moment. It's getting kind of messy. If I take a look at this, all right, this right here is an Ethernet cable. This black one is not meant to connect to the console port, and yet it still has an RJ45 jack, just like the blue one does. So what's different? There's clearly some differences. Well, if I was actually to strip off this plastic or rubber coating on both of them, you would see that there's very thin strands of wire inside here and inside here. As a matter of fact, if I zoom in, let's see here. If I use, for example, this picture, right there. So this shows you sort of like what the interior of an RJ45 jack actually looks like. It actually has multiple wires inside of it. Now, depending on what that cable is used for, it might have some or all of these wires. For example, a console port doesn't necessarily need to have 8 wires inside of it like we see here. It needs far fewer. The colors of the wires will be different. So that's sort of like what makes the difference between the cables. Now, if you're ever taking any Cisco certification test, are they going to expect you to know how many wires are in this versus how many wires are in this? And what are the wire colorings and how are they wrapped together? No, you're never going to need to know that. Now, if you actually go into like manufacturing and you're working for a company that's manufacturing or designing cables, then yes, clearly you would need to know that. But your typical average network engineer out there, 1 out of maybe 1,000 might be able to answer questions like, how many wires are in here? What's the thickness of the copper wire? How are they wrapped around each other? What do the colors mean? You won't need to know that. All you need to know is, okay, this is a console cable, either because I bought it that way or it was labeled that way. This is an Ethernet cable, and you need to know they go in different interfaces. Console cable doesn't go into an Ethernet port. An Ethernet cable does not go into a console port. You need to just be able to identify what's appropriate for the cable, what it should plug into. All right, so that being the case, that's going to be my step number 1 here. So I'm going to go ahead and connect my USB right here into my laptop. Now, let me actually take a step back here before I even do that. So now this is of course Windows here. In the laptop, I'm going to go ahead and bring up my control panel. Put this right here. Okay, so in the control panel, if I go to Hardware and Sound, then Device Manager. Let's put the Device Manager over here. All right, so in the Device Manager right now, it shows me, my monitors, my network adapters. One thing I'm not seeing is that when I plug in this USB adapter, this is called a USB to serial adapter. That's what it's called. USB on one side to a serial on the other. Because a USB interface has electrical signaling and different pinouts and wires than a serial interface does. So this has to convert between the two of them. What we're going to see is when I plug this in to my laptop, in the Device Manager right here, I'm going to have a new port that comes up that did not exist before. So watch real closely. I'm going to plug this in. Okay, I just plugged it in. Look right below network adapters. Now I have something that didn't exist before, COM and LPT. Honestly, I have no idea what LPT stands for. Anybody in the live question feed, just random trivial fact, anybody know what LPT stands for? I hate seeing acronyms and not knowing what they mean. But in this particular case, oh, I think it might be printer. Maybe that's what it stands for. Anyway, line printer. Thank you, Dwayne. Line printer. Fantastic. Well, in this particular case, by plugging that serial to USB adapter in there, it gave me a COM port, COM4 in this case. Why do I need to know that? Because I'm going to bring up some software in my laptop that's designed to send characters to the console port of my router switch. And that software, which is called a terminal server or an access terminal client, it's called terminal client software, needs to know which COM port it's connecting to. And unfortunately, this is kind of random. If I unplug this and plugged it back in again, it could end up as COM6 or COM9, but I needed to know what that COM number was. So I'm going to go ahead and bring up the software right now. There's lots of software that you can use. The software I'm going to use is called Secure CRT, and it looks like this. So let me just minimize this a little bit. So this is what Secure CRT looks like. And I've already got something here called console, but if I right click on that and show you the properties, and Secure CRT isn't the only one. You can download free ones like Hyperterminal, that's one of them, Putty, P-U-T-T-Y, but when you're connecting to the console port of a router switch, you have to have some terminal client software. So just Google for that. Google terminal client software for like Windows 7 or Windows 10 or whatever it is that you happen to be using. And Secure CRT is the one I'm using right here. So, step number one. For example, if I was to do a new connection, File, Quick Connect. So let's say I was doing a new connection. Well, you can see my options here. I'm going to be using serial. Now, if I was actually sending IP packets to this device over the network, if my router switch already had an IP address and I want to send commands to it via IP, then I'd be using like SSH or Telnet. These are applications that run in your laptop. They're specifically designed to take commands you type into the keyboard, put those commands inside of IP packets, and then send those IP packets to wherever you want them to go. But in my particular case, my routers and switches, my terminal server doesn't have any IP yet. So I need to use my USB to serial connection. So that's why I need to select serial on here. And notice, it says, okay, what COM port am I using? I saw that it was COM4. And the default settings for the console ports on routers and switches, and this is something you need to know, is 9600. That's like how many pulses or bits per second, 9600. The rest of it I can leave, 9600, 8, none, and 1. So you'll probably want to memorize that. So this is the basic settings here for connecting to the console port on a Cisco router switch. Select the COM number, and that's why I needed the device manager. That's why I needed this. When I plugged in my cable, it told me. So for example, if I unplug it, all right, it's gone. Now I'll go ahead and plug it in again. Let's see if it gives me COM4 again. So let's see here. Yep, fortunately it gave me COM4, but it's not always going to give me the same number. So you need your COM number, 9600, 8, none, and 1. And that will get me what I need. Okay, so step number one was to plug in that USB to serial cable into my laptop, do all this. Step number two, plug this end of it into the console port of my terminal server right here. So I'm just going to lean over and do that. All right, it's plugged in. Step number three is turn that puppy on. Now, before I do that, I'm going to go ahead and start up my connection here. So I'll just cancel all that because I already have one here. Okay, now as soon as I press the power button on this router, we should see something, hopefully. If not, it's going to be very irritating. All right, great. So there we go. So what we're seeing right now is the boot up process, otherwise called POST, the power on self-test of the router. So it's going to take a minute or so, but it's basically like checking its memory at this point. It's saying, okay, you know, which memory location has my software? Oh, there it is. Let me load my Cisco iOS software. So it's doing that. And then within like a minute or two, it will give me access to the command line so I can actually start typing commands. Now, while it's doing that, why am I connecting to this guy, right? Why am I connecting to this terminal server? Because ultimately I want to make life easier for myself. Instead of having to connect to the console port of each and every one of these devices, I want to connect my octal cable, one end of it to this, and I want to connect these RJ45 ends to the console ports of all my other devices. So while this guy's booting up, I'm going to get out of the line of fire here for a second, and I'm going to do that. And I'm just going to go in a logical sequence right here. So now before I do that, now why not just connect everything together? To me, it makes more sense to go back to my diagram, my whiteboard right here, and build out my drawing. Because once I've built out my drawing and I can figure out, okay, how do I want to connect things together? For example, if I have something here, 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 and here, it makes sense to me that when I'm in my terminal server that I can get to this by, this be device number 1, this to be device 2, 3, 4. So I need to figure out, and because if I go back to my octal cable, each one of these ends is labeled. You can't really see it very well, but each one of these things here has a little label, like this one here says 5, this one here says 4, and that's going to be important because once I connect this, for example, number 4, into a console port of one of these routers or switches, from the terminal server, I'm going to have to type in a command to say, to get to switch number 1, go to number 4. So it makes sense to me that, okay, well, whichever's number 1 on here, here's number 1, I want this to plug into device number 1 in my topology. It would be kind of confusing if I had to type in number 1 here to get into device 5 in my topology. It would confuse me. So that's why I want to work up my topology first before I plug in my octal cable lines.